In this video, I'm going to show you how to use the concave mirror formula. Okay, so let's set up a scenario. Our scenario is to calculate the position and height of an image that is produced by an object 2 centimeters high, which is placed 6 centimeters in front of a concave mirror, center of curvature 8 centimeters. So let's write down what we know. Well, from the question we know that the distance of our object, u, is 6 centimeters. The height of our object, HO, is 2 centimeters. We know our center of curvature is 8 centimeters, but what we don't know is our focal point, and we don't know what our distance of our image or the height of our image is. So that's what we're going to try and find. Well, to start off with, we can basically put down our formula to see what we're going to be using. Now, our first formula is our mirror formula, which is the inverse rule of 1 over f equals 1 over u, v plus 1 over u, plus also our magnification factor or ratio equation, m equals hi over ho, which also equals v over u. So first off, let's find the focal point. Okay, well, when we find the focal point, we know that the focal point is always going to be half the center of curvature. So, in this case, it's going to be half of 8, which means that the center of curvature is going to be 4 centimeters. Okay, great. So let's find V. So, what we're going to be using is our formula, which is going to be the inverse formula. That's going to be made up of 1 over f equals 1 over the distance of the image from the mirror plus 1 over the distance of the object from the mirror. Now we know our focal point is 4 centimeters. We also know our distance of our object. So we'll put that information in. There we go. Alright, so now what we're going to do is we're going to take the 6th and pull it to the other side to put V on its own. So we get 1/4 minus the 6th is going to equal 1 over V. Remember, it doesn't equal V, it equals inverse V. So we solve the fraction, just flipping both sides round, and we get 1 over 12 equals 1 over V, which means that V must equal 12 centimeters. Because it's positive, it also means that the image is going to be real. Excellent. Okay, so now what we'll do is we'll find the height of our image. So in this case, what we're going to be doing is using the other formula. So we're going to be finding hi. Now there's 2 ways of doing this. The first method, which we're going to do, is using the magnification factor. This can also be called the scale factor or the ratio. So first off, we're going to use m equals, just finish this off, we're going to use m equals hi, v over u, which is 12 over 6, which means our magnification factor is going to be 2. So the image has doubled. We then substitute that into m equals hi over ho, and flip it over, so that we get 2 times 2, which is the height of the image, so the height of the object, so it's 4 centimeters. The other way is combining hi over ho and v over u. So in this case, we don't have to work out the ratio or the scale factor, we just cross multiply. So hi in this case will equal 12 over 6 times HIO, which is 2, so again we get 4 centimeters. Okay, thanks for watching.